Good morning, everyone. My name is Scott Beneteau. I'm the Vice President of Sales for Enercare Connections. We're Canada's largest non-utility submetering provider. We work extensively in the multi-residential space. My partner is Omar Salihbegovic. He's an engineer with M, and we work with them extensively in the new construction space. So today we're here to talk about measuring and allocating utility expenses in mixed-use commercial properties. This is something that's been increasingly in demand in our segment. So we thought we'd put together a presentation to provide some guidance to developers who are looking at mixed-use commercial properties and how to allocate costs amongst a variety of commercial parties. So we'll walk through general about mixed-use developments, some best practices in the metering design, and then finally we'll wrap it up with some commercial considerations in terms of how to paper this and put it all together. So what are mixed-use developments? I know when I started in the business over 8 years ago now, a typical condominium was a standalone site. Maybe it would be multi-phase, but it was a classic residential tower with common area dedicated to that particular condominium and residential suites. As we see the growth and intensity of development, particularly in the core of the city, more and more buildings are being converted to mixed use, which can include a blend of any of the things that you can see here. You'll get some rental buildings, purpose-built rental. You'll have some condominium, built in multiple phases. Oftentimes you'll see municipal TTC access that would need to be included, and you'll see parks, recreation, any government facilities, banking facilities, hospitality, office, commercial, retail, and some work-live spaces. So there's a variety of configurations that this can take, and metering is increasingly playing an important role in how these buildings are managed. So where is the industry moving? We see a significant demand for metering in mixed-use commercial spaces as the city is built out. People are looking for more integrated neighborhoods. Work-live spaces are increasingly popular, and it makes use of the city's infrastructure in a way that maximizes the utility for the people. So creating communities is far more important to people now than it is just to have a single residential space. For developers, it's a way to maximize your land usage, your revenue, and many developers are electing to hold and maintain freehold spaces within their developments for ongoing recurring revenue. Here's a couple of examples that Enercare has worked on of mixed-use commercial spaces. With Basis, we have the Emerald Park condos. These are large mixed residential and retail space in Yonge and Bogart area. You can see them easily from the 401 around the Shepherd area. Quite a lovely design, and it integrates mezzanine level with grocery. There's an LCBO there, some common areas, plus the residential towers. And the e-condo as well. That's in the Yonge and Eglinton area, and is also a good example of a mixed-use development that we see more and more common in this particular part of the city as well. Some of the benefits of metering when you get these complex designs is that you have a fair allocation of utility costs based on actual meter data and energy intensity. So by way of example, the energy intensity of particular commercial spaces is different. So the more conventional allocation methodologies are not necessarily applicable as they were used in the past to different spaces within the same complex. And it provides a distribution for shared spaces. There's shared common areas, sometimes shared mechanical systems, and metering can provide a very effective and reasoned way of allocating costs amongst a variety of commercial parties. Planning, I think if there's any message that we would give to developers that are looking at mixed-use facilities, that don't consider the cost allocations as an afterthought. It needs to be considered right up front as part of the design in the planning stages. You need to make provisions for metering early in the design phase. I know when I first started in this business, it was very much an afterthought, and we've worked on projects where it was considered after the fact in these mixed-use facilities. And the technical engineering dynamics were very challenging after the fact. So a lot of the problems that you can run into by a lack of planning can be solved up front by working with a credible partner that has experience with this and is providing the design and consultation in the first instance. There's also questions of liability. We do know of some developers who've had very strained relationships with the commercial parties that they've entered into as a result of the sharing formulas for energy many years after the development was done. So by proper planning, design, and deployment of meters, you can avoid that and have a more pleasant experience through the all phases of the development. So I'm going to pass it over to Omar, who can walk through some specific examples and provide some best practices in terms of that design. Omar?
Thank you very much, Scott. Those two examples that you showed were great projects that I had the privilege of working on. And to Scott's last point, you'll see that a general trend in my portion of the presentation, even though it is more technical sub-metering design focus, is the importance of planning earlier and thinking about sub-metering pre-construction. I'll go through later on in my section of slides here, I'll go through 3 separate case studies. And for each of these case studies, metering design was integrated at different portions of the phase of the project. And you'll see why it's so important to plan for metering in advance. So I'll start with this here, which is basically a chart that summarizes the metering services that we provide. There's a lot of detail on this chart here in terms of design requirements, but I do want to mention that this particularly pertains more to in-suite metering, so single-tenant metering, just because there's more of a standard there. It's more typical. When we talk about really the meat of mixed-use development metering, it's really the common areas and the shared spaces. So that'll come a little bit later on. There isn't as defined of a standard for that because it all depends on who the entities involved are, the size of the common areas, the size of the particular meters that we're doing, the services that we're metering. So we'll see that a little bit later. But just going through quickly here, at the top you'll see electricity. That's typically 1 meter per suite per tenant. Electricity meters are typically installed in common area spaces just because that's where the demarcation point is electrically, so that'll be an electrical closet within your building. And when we talk about communication, we have 2 options. We can either install electrical meters that are power line communication, so it uses the base building's electrical infrastructure, which obviously there's some cost and labor savings there, or we can directly connect all of the meters via communication cables. So that's a little bit more of a robust system. Again, if the metering design is coordinated well in advance, cost and labor become less of an issue. Talk about water meters. We usually include 2 water meters, one for hot water metering, one for cold water metering. That's typically installed directly into the suite. So in the case of a residential condominium, for example, we'd install those behind a vanity or in a general codes closet with an access hatchway to be able to access the meters for operation and maintenance. Water meters, again, we have the option of going wireless or we can go wired, so that's using an M-bus system. And the beauty of the second one there is not only is it more robust, but if we're installing thermal meters within the suite as well, when we're looking at the fan coil units, you can actually connect the water and thermal meters together. Both of them can work on an M-bus system. And thermal meters, we're installing those directly inside the fan coil units. So if it's a 4-pipe fan coil unit, we're installing 2 thermal meters. If it's a 2-pipe fan coil system, we're installing 1 flow meter. And then finally gas meters, which are, of all of these meters, probably the bulkiest. So these are not going to be going in suite. We typically install them at a demarcation point, which is a common mechanical closet or a mechanical room. And you'll see an example of that in a few slides. So this is an example of some schematics that we would provide to electrical and mechanical base building designers. So in this case, these relate all to mechanical meters. So when we sit down and coordinate with a developer's mechanical consultant, these are the types of schematics we would provide that would be incorporated into the design to hand over to the contractors or whoever is installing everything, sort of an all-inclusive package. So this sort of stuff isn't coming way after the fact. And you'll see at the top here, in the top left-hand corner, that's an example of our thermal metering schematic. So you have a flow meter, which we usually install on the return pipe, and you have two temperature sensors, one on the supply, one on the return. Right here, you'll see a typical in-suite metering layout. So I'm using it as a residential condo suite as an example here. Like I discussed, two water meters up here, one for cold, one for hot in a common coats closet or a vanity. Those are in suite. Here are your electricity meters next to the suite distribution panel, which are in an electrical closet. Here are those gas meters that we were talking about. In this case, they were installed in the underground, just a mechanical room. And then you have our thermal meters that go directly inside the fan coil units. And if you take a look at the layout, the thermal meters and the water meters are communicating via this communication cable. So again, this is something that would very easily be able to be integrated into the mechanical, electrical consultant's design and specifications, and it's most beneficial to do this earlier on, pre-tender even, if possible. Okay, so let's talk about actually the meat of mixed-use development sub-metering design, common areas and shared spaces. So I know this is the biggest concern that developers have and the end users have, so the condominium corporations or whoever's managing the properties. Before I even get into designing the sub-metering systems for it, I want to talk about what is a good base building design that accommodates sub-metering well, and what is a poor base building design that doesn't accommodate sub-metering very well. So this first type of base building design is what I like to call scattered type design. So this schematic down here can refer to either mechanical or electrical. So your utility demarcation point in the case of electrical would be a main switchboard. In terms of mechanical, that'd probably be your central plant. You'll notice here that the phase one residential suites are being fed from this point, whereas the residential phase one common area is being fed from this point. So the two have absolutely no relation to each other. We see a lot of electrical mechanical designs this way, where loads are sort of being fed from all over the place. This is very difficult for metering. It often results in a complex metering design. More meters need to be deployed, and we need to add meters, whole bunch of meters, to be able to group certain loads together to achieve the desired billing allocation. So this is kind of a metering designer's worst nightmare from a design standpoint. This, on the other hand, is the better way to design a building that can accommodate sub-metering. And it's what I like to call the branch type of design. So you'll notice all of the residential distribution is grouped together, all of the shared facilities are grouped together, same thing for commercial, and perhaps if we have a hotel portion to the building, are grouped together. So this will most definitely result in a simpler metering design. It will involve less meters being installed and deployed to the site, and in this case we can actually utilize deductive metering to our advantage. So if I go down here, take phase one again from the residential portion as an example, if I'm metering all of the individual suites already, all I have to do is install a bulk meter for phase one, and I can easily subtract certain loads to get my common area, as opposed to putting individual common areas, hundreds of them, throughout the site. You'll see a little bit of an example of this in my case studies. So this is my first case study here. I've chosen this one because it's a mixed hotel and residential property. So without naming any names, I've shown here a visual depiction of the entities that are involved. So on this property, we have a residential condominium, a hotel portion, the developer's actually head office is on the roof, and we have some shared facilities between everybody, and there's some two-way shared facilities. So those two-way shared facilities are just between the condominium and the hotel. What did we provide for this project? We provided electrical sub-metering in suite and common area, nothing mechanical. You'll see that in my subsequent case studies. The metering design coordination happened post-construction. So what happened for this project was we did come in pre-construction, but it was decided that we would meter the common area in bulk, and then we would distribute the common area based on square footage. So there's a little pause there because I know that it's kind of a ridiculous model, right? Because based on square footage doesn't tell you a lot about usage and who's using more or less, right? So the developer came to us after the building was already completed and said, okay, we've been working with hotel management, with the condominium corporation, property management, everyone sitting around the table. We need to meter the utilities in the common area specifically in order to determine who's using what, so that we can allocate the utility bill. This obviously resulted in many discussions and a very complicated metering design because of two reasons. One, we coordinated everything post-construction, and two, the electrical design was the scattered type. You'll see on my next slide. Because of that, obviously additional metering and labor costs, significant costs post-construction. So here is the electrical single line diagram for this project. So I can spend 2-3 hours taking you through this, but I won't. It obviously didn't come color-coded like this. The color coding is a result of our discussions with the developers and the consultants. So everything that we've color-coded here in blue, you'll see over here, is dedicated to the condominium. Everything that's orange is hotel. Everything that's purple is a shared facility. Everything in pink is a two-way shared facility. So what do I mean by far from perfect allocations in this case, and far from perfect metering? If I draw your attention just to this electrical splitter over here in the main electrical room, you'll notice that there's a whole bunch of mechanical loads that are being fed off of this splitter. Most of them are orange, so most of them are hotel loads. 2 of them are shared facilities being shared between everybody. Now, to perfectly meter this and allocate the utilities, we would have to put a meter on every single one of these mechanical loads, right? Which is pretty inefficient from a cost perspective. What we did was we said, okay, because most of the loads are hotel, we're going to group this splitter as a hotel splitter. That's what I mean about when I say far from perfect allocations on this project. We got close, we didn't get to perfect. This is the resulting allocation summary. So again, lots of stuff on this slide, but up here is the color coding that I mentioned for each entity. Here you'll see all of our meters that we installed. They're all color coded to correspond to the entities. And then at the bottom here, you'll see what we call a virtual metering schedule. So this is how do we use the meters we've installed on site, and how do we group them together or subtract, add certain meters, have formulas to reach our desired billing allocation, to what the condo corporation, property management, hotel management wanted. Basically, point of the story, it was a little bit of a hot mess. So not the perfect scenario. So next best thing. In this case, second case study, entities involved are 3 new condominium towers, residential, a grocery, large grocery space, including some additional commercial as well, shared facilities between all of these entities, and then 2 previous phases, so 2 condos that were completed years prior to this project. Okay, what kind of sub-metering did we provide to this site? We provided electrical for in-suite, but we also provided electrical and mechanical for common areas. So not mechanical metering within the suite. Again, electrical-based building design, I'm going to use electrical as an example here, was scattered. So not very accommodating to sub-metering. However, we did coordinate the metering design while construction was happening. So again, it's a little bit better than post-construction coordination, still not the best. We'd prefer to get in there before construction had even started, before they had even broken ground. Because of the scattered type of design, it resulted in pretty complicated metering design. However, because of the timing, we were able to get pretty close to perfect allocations. And I do have to give credit to this developer for this project because he really had the foresight to take into consideration sort of the end user, the condominium corporation and the tenants, and how they would want their utilities to be allocated. So everyone in tower A, B, and C was paying for what they were using. What do those common area groupings look like? Let's just look at the electrical distribution to begin with. So we have 1 hydro bulk meter. Under this hydro bulk meter, we have 2 towers, a tower A, tower B, and everything that's involved in those towers. So their common areas, their residential spaces, their commercial spaces. So this alone here is a problem, right? Because you have 1 utility meter that's metering 2 separate condominium corporations and entities. You need to allocate those utilities fairly. So this alone is an issue. We have a second bulk meter that's metering tower C, so these guys aren't so bad. They have their 1 bulk meter metering their commercial residential common area spaces. Okay? and you have that large grocery space that has their own hydro bulk meter as well. So not so bad here either. Then you have the monster shared common areas. That all falls under that hydro bulk meter 1. So this guy's a pretty big issue for this project. Okay, how do we allocate the price of this utility bill up here? So we sat down with the developer, we sat down with the consultants, and we said, how do you want the common areas to be split? And this is the result of that. They said, we want Tower A to pay for its own common areas. Makes sense. We want Tower B to pay for its own common areas. Makes sense. We want the P1 space to be metered and billed separately because everyone would be using the P1 space. This is something we see very commonly in mixed-use developments. The parking area has public parking. Sometimes commercial units are down in the parking garage, so the parking is something that we see very commonly being requested for separate metering and allocation. Outdoor common areas. They wanted us to meter everything outdoor separately and bill that separately. Reason being, those 2 previous phases that I was talking about would be using some of these outdoor common areas. So it was courtyards that were built and parks that were built in the area of the new phase that those 2 previous condos would also be using. Tower A, B joint common areas. So Tower A and B in this case were physically joined. So there was some shared corridors between the 2 towers. Those needed to be separated out from that bulk bill. Finally, some central plant metering. I'll go into that into more detail about that later on in the presentation. Okay, what else? There's common areas that were Tower A, B, and C, all shared. How do we determine those? So we take this hydro bulk meter number 1 and we subtract everything under that bulk meter. That is Tower A, Tower B, residential, their own common areas, the P1 common, the outdoor common, and the result is what we call this joint common area. That's Tower A, B, and C, everything joint. Finally, the last group was Tower C's common area. That's a fairly simple calculation. You're subtracting that hydro bulk meter number 2 and you're taking away all the residential and commercial within that tower. You get their common area. So voila, here are 8 common area groups. Okay, how does that manifest on the actual electrical design? Well, here it is. So this is a typical panel schedule that an electrical consultant would provide to contractors and a developer for a new construction project. What we've done is, right here on the left, we've color-coded all of those common area groups, and we've identified on their panel schedule each circuit and what group they belong to. So everything in green here, central plant, everything in pink, central plant, and we have a makeup air unit up here that belongs to Tower B, so that needs to be separately metered. And under that, we've actually, even for their reference, provided what meters are required for ease of coordination with contractors. Okay, so this is how this previous sort of allocation that you see manifests itself on the design. Okay, and then finally the billing allocations. So here are our groups up here. I'll go through just for Tower A. What did the developer want? So they wanted Tower A to receive 1 bill, that's their dedicated common area. So that's group 1 up here, which we discussed. And then Tower A would get another bill that is their portion of shared facilities, which is a percentage of group 3, so P1, a percentage of outdoor, a percentage of A, B joint, and a percentage of the overall joint. Okay, and the same goes for the rest of the towers and phases. Okay, so lots of coordination, but we were able to achieve everything because it was done in advance of completing the project. Moving on to my final case study. So this is sort of the best case scenario for us. You'll see here a visual depiction again of the entities. So here we have a large condominium tower. We also have a rental apartment tower. Here as well we have a large bank that spans 2 levels, and we have quite an extensive commercial concourse, and then we have shared facilities between everybody. Okay, type of submetering, here we did electrical, mechanical for both suites and common areas. So basically every kind of metering type that we could provide. The mechanical, I'm going to focus on mechanical because I've talked enough about electrical now, was this what we call branch type base building design. Metering design coordination happened before construction and actually before tender. So this is the best case scenario for a metering designer. Because we were installing thermal meters on this project, we actually had to meter the central plant as well. So I'll go into a little bit of a detail about how we do that and why we do it. But the point of the story that you should take away from this particular case study is that because it was coordinated so early, the metering design was quite simple and the allocations are fairly seamless. Again, the developer in this case had great insight into what the end user would want when the project was completed. So let's go into it. Let me show you an example of what I mean by branched base building design. So this is a heating loop for the commercial portion of the building. So put aside the residential. Right here on the left-hand side, you'll see the main commercial heat pump loop. So this up here is coming from our central plant. We have one main thermal meter that we've installed on the output of the central plant. And then here the heating loop is distributed to the commercial spaces. So the commercial spaces span from the P2 level all the way up to the 3rd floor. We've also installed one thermal meter on the main loop for the 2nd floor. So if we take a look at that main loop over here on the 2nd floor, you'll see this meter in green is the exact same meter over here on this side. Why did we do it this way? So you have a bank that has multiple heat pumps inside. Then you have, also on the 2nd floor, you have individual commercial units. So we said, okay, we put one main thermal meter at the input of this floor, and we put thermal meters on each of the individual commercial units. We no longer have to meter the bank via individual thermal meters, because we take this meter, we subtract all of the commercial meters, and voila, we get the total consumption of our bank. Okay, and there's quite a lot of heat pumps in this bank because it's a huge space. So we're saving a lot of money on meters and installation cost. Okay, if the bank's heat pumps were fed from various loops in different locations, we would not be able to do this. Okay, so this is simplifying the metering design significantly. While we're on the topic of thermal meters, how do we derive rates for the thermal meters that we're installing on site? Okay. The key to this is central plant metering. So you have a central plant in your building that is consuming electricity, gas, and water. Okay, so you have up there, I shouldn't say up there, sometimes the central plant is down there as well. You have chillers, pumps, fans, which are all consuming electricity. You have your boilers for heating, which are consuming gas. You have some water being consumed by typically your cooling loop as well. So those are your water meters. So we install electricity, gas, water meters in the central plant. That's one part of it. Second part of it is this big guy right here, this thermal meter that we're installing at the output of our central plant. Okay, so this thermal meter measures the flow rate and the change in temperature coming out of the plant. So you multiply your flow rate by your difference in temperature, you're getting an output energy in joules or megajoules. Okay, and then you have your individual thermal submeters here. So I put one here on each of the loops, commercial, perhaps hotel, shared facilities. You can also go further down the line here, and we're installing thermal meters inside the fan coil units for all the individual tenants. So how do we use all of this information? So having our utility bills, our electricity, our gas, and our water utility bills, we can determine the total cost of the central plant. Okay, because we're metering the central plant, we have utility bills, whether it's from Enbridge, Toronto Hydro, City of Toronto. We determine the total cost of our central plant. Then we've installed a main thermal meter at the output of our central plant that gives us the total energy. So we take the total cost of the central plant divided by the total energy that's being output of the central plant, we get a rate in dollars per megajoule. You can now use that rate, multiply it by your individual submeters, you're recouping the cost of your central plant. Okay? If you are thermal metering every single entity within the building, you'll recoup the entire cost of your central plant. If you're only metering certain tenants or certain entities within the building, you're going to have a leftover amount in the central plant cost that you can then allocate through your condo fees or hotel management fees, whatever it is. Okay, so that's sort of thermal metering and thermal rate derivation in a nutshell. Going back to this case study, here's our end result billing allocation. So we understand that in most of the metering projects we work on, not everybody is technical. So not everyone's going to understand the meters that we're installing and why we're putting the meters at certain places that we are in a building. But we make sure that for every project, we sort of generate this end result billing allocation that sort of anybody can read. You don't have to be technical. So for this case, you'll see over here, this is everything that's being metered within the condominium. Everything to the right is everything that's being metered under the rental apartment. Along the vertical axis here, you have your different services. So we've organized here exactly what's being metered per entity. And I'd like to draw your attention, I don't know why that's happening. Draw your attention particularly to what's here in purple. So there's a joint common area portion in both the condominium and rental apartment that we're metering separately, and we've identified here in our end result billing allocation. So again, this project hasn't even began construction yet, but we've coordinated all of them sub-metering for it already, and it's already been integrated in the pre-tender packages. So no issues in terms of coordination for this. Finally, to conclude, if you haven't already gotten the gist through this portion of the presentation, the biggest takeaway is sub-metering has to be coordinated early on for ease of coordination between everybody. I can't begin to tell you how many angry calls from contractors I've had, or meetings with developers and contractors to determine how meters should be installed and where they go or whatnot, because metering came in so late after the design was completed. Branched base building design, so we talked about that. I showed you the example of the mechanical loop is very important. I showed you why it's important for us to meter the central plant when we're determining thermal rates. Coordination between all parties, you'll see I've bolded it there, and reviewing the resulting billing allocations as well. So for all of those non-technical people who don't know where meters are being installed and what kind of meters we're using, what are we getting from our meters, and what does it all look like at the end? With that, I will turn it over to Scott, because I know he has some more on that topic.
Thanks. Thanks, Omar. I just want to conclude the presentation with some of the commercial considerations that need to go into this. I think Omar walked us through the complexity of the design and the foresight that needs to go into planning for metering and allocation. But at the end of the day, you have to be able to put it in writing, you have to put it into a contract, and you have to provide documentation and management, ongoing management with all the parties. So within metering itself, not every single space can be metered. It doesn't always make sense for metering in every situation. And even where there are meters deployed, there are shared facilities. So there are cost-sharing formulas that need to be considered up front. So what's the methodology that you use for shared spaces even when it's metered? Is it a ratio to the number of suites? Is it anticipated usage? We've seen where there's a TTC public access, developers take the position that they should pay a certain percentage more than perhaps the residential or other commercial. So there's a variety of ways that within metered spaces you can allocate those costs. So you do need to give some consideration to how that's going to play out. It has to be reasoned and easy to explain. You don't want to make it too complicated, as you have a variety of people within residential, commercial, mixed-use developments, and their level of understanding can vary. Working with a condominium board member is quite a bit different than working with perhaps a well-established grocer or retail outlet. Administration fees, depending on how you deploy your metering system and when you get it in, it can drive significant costs. So it's important as a developer to establish a reasonable baseline of costs, carrying costs on a monthly basis. This can take the form of monthly administration fees, equipment rental fees, or some developers may choose to make a capital contribution towards the metering to reduce the fees. But it shouldn't be an afterthought. As Omar walked through, the design and intensity of the metering can be very costly, particularly if you're doing it post-construction. Those costs can rise very, 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 very quickly. So you need to set expectations with your customers and all of your stakeholders, what the metering is going to cost and the benefit that they derive from those costs. I also like to call out the quality of the equipment. Where you're not required for allocation to use Measurement Canada approved electricity meters, however, we do highly recommend it. It really speaks to the credibility. To have a federal agency verifying the accuracy of the equipment that you're deploying speaks to the credibility of the program. So you're unlikely to get disputes in terms of the actual readings itself. Where you're deploying mechanical meters, water, and particularly thermal, we recommend using equipment that's built to the EN 1434 standard. Now that's the European standard that regulates the accuracy of thermal meters. We use exclusively a GWF product through our partner QMC. It's Swiss made. It's one of the best meters on the planet. So when you're going to talk to your customers, you want to be able to point to the quality of the equipment and the accuracy of that equipment. Legal considerations. If you think the metering is complex, wait till you try and put it all in paper. It can be a daunting task for respective legal counsel to draft this in a way that's easy for everyone to understand and that ultimately ties together. So it's important that the declarant has a shared facilities agreement that specifically delineates how the utility arrangement will be allocated. We see some that are very general and that all the parties will be responsible for certain utility costs. We recommend getting into more detail at the declaration phase with proper planning so that everyone who's entering into an agreement has an understanding of what's going to happen and what their particular utility costs will be and how they're allocated. It should talk about rates, any formulas if available, and if you do this early enough in the design, it's easy enough to include the formulas and the ratios so that it's not after the fact people are arguing about who's responsible for what percentage. It's clear, it's in black and white, it's formed part of the declaration, and it's managed through the shared facilities agreement. The agreements with submetering providers generally are long-term, and in these mixed-use commercial developments, you have multiple commercial parties. So you do have to spend some time and consideration to how one might unravel such an arrangement should the need arise over time. And you also shouldn't forget about any of the freehold lease arrangements that are there. The leases are just as important as any other documentation, and in our experience tends to be a bit of an oversight. So when you're trying to lease a large commercial space or even some of the small mezzanine retail type spaces, it's important that the lease agreements contemplate any of the allocation and sharing formulas that you've agreed to up front. And finally, I think the critical factor in all of this is, notwithstanding the fact that you might have great design, you've really thought it through, at the end of the day, you need to manage the relationship with the property manager, the condo board, and all the parties to the agreement. So having the clear legal documentation that articulates how the program works is very important, but it's really up to people to go and meet with the board of directors, meet with the leaseholders, meet with the shared facilities manager, and explain the vision and the rationale behind the sharing formulas in the metering deployment. As I said, these things can get very expensive, so there may be some sticker shock in the first instance. So it's incumbent on your submetering provider and the property managers to educate themselves on how the program works, how you arrived at the conclusions that you did, and why it makes sense for them long term. And if you do manage the relationship closely and you maintain open and active communication with all the stakeholders in your mixed-use development, combined with the foresight of proper metering design, you can get into and out of your project seamlessly with all of your stakeholders. So that's it for today. If you have any questions, Omar and I are happy to answer them.